This is GCSE Papers Shadow Set 1, higher tier Paper 2. It's the one with Thursday 6th of June 2019 written on the front. Okay, this time I'm going to take a look at question 12. This one is all about area of a sector and the perimeter of a sector. Typical grade 7 style question. So let's have a go. So it says OAB is a sector of a circle, centre O, radius 7. We're told that the area of the sector is 30 centimetres squared. And what we need to do is calculate the perimeter of the sector, given our answer to 3 significant figures. So we know that the area is 30 square centimetres, and we need to work out the distance around the edge, the perimeter of the sector. Right. So we're given information about the area of a sector. Okay. So what we need to know is the formula for the area of a sector. Now the formula for the area of a sector is something that you would need to learn, and that is theta over 360 multiplied by pi r squared is the area of a sector. Let me just briefly explain that. Theta takes the place of the angle, so this angle here, out of 360. So this angle out of 360 is because a 360 would relate to the whole circle, but we've only got a certain amount of it, a certain angle in it. And pi r squared would be the area of the whole circle. So this formula makes sense because we've got a certain angle out of 360, a certain amount of 360 of the whole area. Okay, and so that's why this formula is the way it is. Now, let's relate this formula to this question and this information. We're told the area of the sector is 30. So therefore, I know that theta out of 360 multiplied by pi r squared is 30. In this case, rather than put theta, I'm going to call that angle x. And I'm now going to replace, I'm going to put this formula specific to this question. So we know that x over 360 multiplied by pi multiplied by r squared is equal to 30 square centimetres. Okay, so we can now, by working backwards, we can work out what this angle is, right? Because also we know what r is, the radius. The radius, we're told in the question, is 7 centimetres. This would be the radius of the whole circle. So let's put that into our working. We've got x out of 360 multiplied by pi multiplied by 7 squared is equal to 30. And as I say, by working backwards, we can work out the one unknown in our formula. So to work backwards, all I need to do is take my 30, divide it by 7 squared, because working backwards, this is a multiply. Divide it by pi, again, working backwards, this is a multiply. And then multiply by 360 because we're dividing here. So if I turn the calculator on, right, we've got 30, working backwards, divided by 7 squared, divided by pi, and then multiply by 360. It just gets rid of all of that working backwards, and that will tell me what x is. So x is 70.158097336. Okay, working backwards, x is 70.158097336. And that would be degrees because we're talking about that angle there. That is what that angle is. No, it's definitely not to scale. Right, now I'm going to leave that in the display because it's likely I'm going to need that later on, which also brings me on to why I've written the whole calculator display down. You should not be rounding. I certainly should not be putting 70.2, right? Don't round in the middle of doing your working. You need to only round for your final answer, right? You should be using at least 5 or 6 decimal places if I'm using this number again, and I will be using this number again, okay? So in terms of just writing it up on here, I will round it, right? But if I'm using it in my calculator again, I'm going to be using the whole display. So what we've got is we now know this angle. Okay, we've worked out this angle, right? And that would likely have got us half of the marks so far. So let's go back to the question. The question says we need to work out the perimeter of the sector. So that's the distance all the way around. Well, that's 7 plus something plus 7. So we need to know that length there. We need to know the length of this arc AB, the length of this arc, and that's the next formula that you would need to know. We've got the area of the sector, we need to know the length of the arc length. Okay, now the length of the arc is very similar. It would always be theta out of 360 multiplied by pi d. All right, so we've for the same reasons as the way we did the area, it's part of the whole circle multiplied by the circumference, because we want a fraction of the circumference, we want a part of the circumference. Okay, now I've written theta there because that's the full formula, except the fact is we know that this angle is 70.15809.736 degrees. Okay, so I can use this formula with my number, my actual angle, to work out the length of AB. Okay, so let's do that. Arc AB is going to be 70.15809.736 out of 360 multiplied by pi multiplied by the diameter of the circle. Remember, the diameter of the circle would be two lots of the radius. So 2 lots of the radius is 14. So arc AB, get the calculator, it's still in there. So I'm just going to press divided by 360. So it's 70.15809.736 divided by 360, multiplied by pi, multiplied by 14. Press equals to come up with a fraction. So in fact, I'm going to write my 67ths down, press the SD button, and that gives me the decimal 8.571428. Actually, that's recurring, and that would be centimetres. Okay, so I now know the arc length. The arc length is 8.571428. Right, that would be this bit here, 8.571428 centimetres. That's the distance from A to B. The question didn't just want the arc length, the question wanted the whole perimeter of the sector, the distance all the way around the sector. So that would be 8.571428 plus 7 plus 7. So I can just take my answer from my previous one. So I can say the perimeter of the sector is 8.571428 plus 7 plus 7. Get the calculator, it's still in there, plus 7 plus 7. And there's my final answer. That's the perimeter of the sector. It's 22.571428 recurring centimetres. However, the question does say give your answer to correct to 3 significant figures. So 22.6 centimetres correct to 3 significant figures.